Welcome back to day 37 of LeetCode grind. Solve or go home. 30 minutes. Solve or go home. Construct target array with multiple sums. Okay, given an array of integers target from a starting array A consisting of all ones, you may perform the following procedure. Let x be the sum of all elements currently in your array. Okay. Choose index I such that 0 less than or equal to I less than or equal to target at size, and set the value of A at index I to x. Okay, you may repeat this procedure as many times as needed. Return true if it's possible to construct the target array from A, otherwise return false. Construct a target array from A. Okay, A is a starting array consisting of all ones. You may perform. Okay, so starting array of A, and then this is line x with the number. Okay, choose one index I should say. Set the value. Okay, so you start with 1 1 1, sums 3, choose next one. Oh, I see. Okay. 5. Oh, okay, so you basically you can make an array of any size to start, or is it has to be same size as target?
Same size as target.
Oh, that's okay. Okay. So basically, what you want to do is see if the sum of your array of that you have is equivalent to any of the indexes. If it's not, then you're hosed already. If it is, then you replace it, and then you check the sum again and see if that can replace anything. If not, you're hosed.
No, but you can repeat this forever, right? So look at the last example.
But can you repeat this forever? Okay, 8 5. So you have an array of 1 1. Right? So
okay.
1 1, and your target is 8 5. So your sum of 1 1 is 2. So it can't go in here at all. So that's broken. But wait, when you you're saying you can put it in as like 2 1 and then sum it again? Is that what you're saying?
Yeah, you repeat the cycle.
Oh, I didn't know you could do that. Okay. Shit. Okay, in that case. Okay, if you can sum it each time. If you just keep summing it.
Yeah, but then if you so if you do bottom up, it's gonna take. There's like many possibilities, right?
What do you mean by bottom up?
Like if you're summing it from 1 1 all the way to target.
What do you mean by coming 1 1 all the way to target? Oh, like as in like keep summing until you find a target that you can replace.
Yeah, because you don't know what to do, right? So
Yeah.
2 1, it can either get to 2 3 or it can get to 3 1, right?
Yeah. Yeah.
So instead of going from bottom up, what should we try?
Top down.
Okay. So in the top down, must be the last move.
What must be the last move? It must end as 1 1s.
No. It's not top down. What was the last move? What was the last number that you put into the array?
Well, when you're saying top down, you're saying basically start at a target and see if you can build.
Hmm?
You can build.
We can get back to ones.
See if you can get back to 1s. Exactly. So the last move, as it were, is your array ends at 1 1s, right?
Okay, fine. What was the first move from the target?
You subtract the sum of the length of the array. Well, or you subtract the length of the array times 1 from any of these, any of the numbers.
No.
No, why not?
Is this, that's only if that was your first move.
I'm not sure what that means.
Okay. At the very beginning,
Mm-hmm.
why does 111 become 131?
111 becomes 1. Because then you replaced an index with the sum.
Right. If we were going from 131 back to 111, why? How would that work?
Oh, so you would 131 back to 111. Well, you know the sum of the length of the arrays is 3. So because this is 3, that means you know you replaced it. So you can just plop 1 back in.
Okay. The transformation from 111 to 131
Mm-hmm.
changed.
The index 1 changed.
1 to 3, right?
Yeah.
What is the change?
The change is the replacement of 1 with the sum of the length of the.
Yeah. So, what? Um, what's the difference?
2?
Okay. And where does 2 come from?
I guess it's length of array minus 1.
Sure. Okay. Then let's look from 131 to 135.
Okay.
Change.
1 to 5.
Okay. And what's the difference?
4.
Yes. And where does 4 come from?
The sum of the array, the minus 1.
What do you mean by minus 1?
Well, sum of arrays 1 is 5. So 5 minus 1 is 4.
Okay, sure. Okay. And then from 135 to 935, what changed?
1 to 9.
Okay. And what's the difference?
8.
Where's the 8 come from?
Sum of the array minus 1.
Okay. Let's say we extend this again to say I don't know. 1735, right?
Mm-hmm.
And what would be the difference?
9 to 17.
And which is the difference of 8. Where's that 8 coming from?
That 8 is impossible to do, isn't it? Right. Because then if you had 935, right? And then you're saying it goes to 1735? Is that what you're saying?
Right.
Is that even possible? I don't think that's possible. Because then, if given 935, how do you get a sum of 8? If you had 3 and 5,
You have 935. So what's the sum of that array?
the sum of this array is 17. Oh.
Okay, so we're okay. Let's
Oh,
put
my bad.
17
All right. Okay, yeah, that is possible. Okay. So in that case, 17 is it's the sum of the previous array minus the index, the value of the index that you're replacing.
Okay. What is the sum?
17.
What is the sum minus the value of the previous index?
8.
So you're correct in that. Yeah. So okay. So the difference between the one step and the next step is going to be sum of all the elements that you choose that are not the one that you're changing.
Okay, sure.
Okay.
Yeah, so it's just 3 plus 5, which is 8.
Right.
Okay.
So can we work backwards from the most up element?
With the most what?
We'll work backwards to construct 111 from 935, 1735.
Okay, I guess. Wait. So, given 1735, you know 17. Okay, so 17 is basically. Oh, you can solve for the previous index by just subtracting the sum of the other indexes. So 17 drops back to 9.
Why 17 and why not 5 or 3?
Because then those will go negative, and you don't want negatives. Because then some of
Right.
the.
So my question to you is, which
Which
index
number do you
contains
drop?
which index is the one that was modified last?
The largest index.
Correct. Why is that?
Well, greedy algorithm suggests that for sure, but also, um, because yeah, if you try to reduce a different index, it's gonna go negative, and that's clearly wrong.
Okay. Now, what can you say about the sum of the array after every step?
It increases.
Okay. And so if it increases, then what was, and we were setting one of the elements to that array total, uh, then why is the maximum element thing that was last set?
Why was the maximum element the thing was the last set? Because it's equivalent to the previous sum.
I think you get it, but I'm not sure.
Well, you repeat the question. You cut off with a lot, so I'm not really sure.
Okay, using the observation that the sum increases per iteration,
Yes.
why is it that the maximum element is what would be the last thing to be set?
Because if the sum increases, that means the number is bigger each time, and in that case it has to be the largest index, because then otherwise if it was placed somewhere else, that index would be the largest index. So it's
Right. I think you have the idea. Okay, so now we know that the last element was the one that was changed most recently.
hmm then you reduce that one back to previous level. So basically you're
Right.
just constantly looking for the max index and reducing it by the sum of the other elements.
Right. So, okay, and then can you work backwards from 1735 to a solution, I guess?
Yeah, so that's pretty simple. 1735, so the max is 17, so you subtract 8, which is the sum of the other ones, so you get 9, 3, 5. And then this 9 is still the largest, so you subtract again, then you get 1, 3, 5. Now 5 is the largest, so you subtract out 4, and you get 1, 3, 1. And then 3 is largest, so you subtract out the other 2, so it's just 1, 1, 1. And then the second you reach 111, you return true. If you never
Okay.
hit 111, then it's false.
Okay. Right. So, this is good. That means you know that the algorithm works if you iterate through this. So what if instead you had something like I don't know, 8,017,355.
Wait, say it again.
8,017.
8 million or 1 million?
8 million.
Okay, 8 million to.
1,017,017 also works, I think.
Alright, 1, 2, 3, 1, 2, 3. Okay, 17 and what was the other one?
8,017,017 is the number.
8 million and 17? 1 million?
It's all one.
Okay,
It's all one number.
Okay, what's the other numbers?
3 and 5.
3 and 5. Okay. So if I subtract out 8 from this, that's 1,000,009. Okay. Okay, I'm not gonna write it out. So 1,000,009, 3 and 5, and then you're gonna constantly subtract 8 from it until it's less than 5. The question is, if you keep subtracting 8, does it actually go to 1? I'm not sure about that. So basically, you have to do a see is 8 divisible by that number.
Right. So the 1,017,000, if you subtract 125,000 times of 8, you get back to 17, right?
Wait, does that work? 1,017,000. Say that again. What did you say? 1,017,000, and then you subtract what?
You subtract 8, 125,000 times, and then you get back to line 4.
Wait, is that true? 8 times 125,000 is 1 million. Oh, okay, you're correct. All right, is that why you chose 1 million?
Right.
Okay.
I'm choosing something that is a multiple of 8.
Yeah,
right?
I can't do math. Okay, so yeah, this would get there eventually. Yes.
Right.
So, but that's I see. I think I see what you're getting at. That's a very costly operation. So I think instead of subtracting each time, you're trying to do it like a mod.
Right. So your first, I think the algorithm that you iterate on line 4 is fine. But you can kind of jump to some later step by doing mod operations, right?
Mm-hmm.
Okay, cool. So
you take the largest number and mod it by the sum of the others to just drop it down instantly, and then
right.
And then you just keep going with that, and that should work.
Okay. Let's see. Okay. So let's examine some edge cases for where this will not work. Okay.
Mm-hmm.
So what happens if we had 835?
Okay, so if you do, wait, why is this not working?
Or 735. Let's do 735.
Okay, sure.
For a new example.
So if you're 735, 7 is largest. So 7 mod 8 is actually
Well, first, 7 mod 8 is
1.
Still 7 because 7 is smaller than 8.
Oh, right, yeah. So if you can't mod it, then you just return false.
What do you mean you can't mod it?
Okay, if you mod it and it's the same number, then clearly it doesn't work. You can't get back to 1. You can't get back to 1. Yeah.
If you mod it in the same number, that means you're smaller than
than the sum of the others. But then because this is the max index, this is the one you want to mess with, and because it's less than the sum of the others, then clearly you can't get back to 1. So that's a false case already.
Right. Okay. So basically, if your number is smaller than the sum of everything else,
then you're false. You cannot get back.
Okay.
Yep. Okay.
Okay. Cool. So keep that in mind.
Mm-hmm.
What about 835?
835. Okay. So 8 mod 8 is 0, right? Is that 1? Is that 1? What's 8 mod 8? Is that 0?
It's 0.
Yeah. So 0 is wrong too, because 0 is bad. You don't want zeros. You want ones.
Wait. Why is 0 bad?
in the context of this question, it's bad. Like if you get 0, you can't get back to 1. That's bad. You want to go to 1. You don't want to go to 0.
Right.
So if the sum is equivalent, that's also false.
Okay, but there's gonna be okay. What if you had just like 8 1?
8 and 1. Okay, so I guess you would do 8 mod 1, which is 8.
8 mod 1 is not 8.
Wait, what's 8 mod 1 is 1.
Oh, 8 mod 1 is 0.
Is it? Wait, why is that?
Because 8 is a multiple of 1.
Oh, you're right. Wait. Yeah, okay. But in this case, you can actually go back to 1. So you can't.
Right,
you can't
keep subtracting 1.
Yeah, so you can't rely on that. So, okay.
I mean, Can you rely? Or do you just have a special case for one because one can do anything?
Um, yeah, I guess technically you're right. Because then, yeah, one is guarantees you can get back to one for sure. Because you can just keep doing that operation multiple times. So what you're saying is, if it's if it's if you're modding your sum and you get to zero, unless the sum is one, then you're false. But if the sum is one, then you're true.
Right. But the sum can only be one if
It's just one one. That's
if there's just an extra one there,
yeah.
right?
Mm-hmm.
Okay, cool. So I think you pretty much covered all the edge cases.
Okay.
Okay. So what's the best data structure for this if you always need the maximum each time?
A heap.
Okay, good.
Okay, so you're given the target array. Okay, so if I have this target array, okay, then if I'm going backwards, if I store this in a heap, I pull out 9, and then, okay, so in that case, if I pull out 9, the heap structure has 3 and 5 in there, but we don't know the sum of 3 and 5.
All right. So you
Wait,
want the
can you call
total?
a sum on a heap?
No. Well, you can have the total when you build the heap.
Oh, right. So you're saying have a variable that stores total, pull
Right.
out the
Right. Something like
pull out the max, and then subtract the max from that. Then you'll know the sum of the rest of it.
that. Right. 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 Exactly.
Okay, and then you just keep that total running total updated as you lower your indexes.
Right. Right.
So yeah, so you
And
pop
when are you done?
when your sum is length of the target, or
Not exactly, right? Because you want to. What's your final
you want it to be one
array
one
look like?
ones.
Yeah. So that means your heap is gonna be all ones, right? Or
Well, yeah, it's gonna be all ones, but then
okay, so how do you know when you
when your
hit the
total
ones?
yeah when your total is either equivalent to the length of target, or if you hit one of those edge cases.
Uh, okay. What if you heap pop and then it's a one?
Okay, well if he pop with one, then you're guaranteed that you're done because it's that if your max is a one, then they're all ones.
Okay, good. Then that could be your exit condition. Then you don't have to check anything else, right?
Is I mean yeah, that works. Is that cleaner than checking the sum? I guess. I mean you have the running total at all times. It's pretty simple to check, isn't it?
Sure.
Okay, fine. All right, yeah. So okay, so algorithm is okay. Store the target into a heap, pop out the max, do a mod on the rest, and then pop it back in, and then keep running until you pop a one out. And then if you don't pop a one out, meaning one of your edge cases triggers, you return false. So if you pop a zero out, that's false unless you only have a one present. But how do I know that? Okay, wait, what was the other edge case was if if you're if you pop out that element and that element is less than the running total, then that's also false. So there was two edge cases, right? So if popped element is less than running total, false. And then if popped element is 1, you're done. True if popped element, well I guess you won't pop out to 0 actually. So it's not popped element. So you're checking if your mod returns 0. If mod returns 0, check if there's only one other element.
Well, no, you can check if the total is one.
Oh, right, because the other element. Oh, yeah, that makes sense. If mod returns 1, check if running total is 1. If mod returns 0 and running total is 1, return true, else false. Okay, I think that's the 3 cases you care about. So basically, I just have to store this into a heap. Import heap queue for targeting, whatever, num target heap. I didn't instantiate a heap. Queue that heap push heap and num times -1. Okay, that will get me the whole thing. And then while, okay, so while, it shouldn't be a while. Maybe, wait, it could be a while, but then I would need to, it shouldn't be based on heap, it should be based on the exit condition. So I need a boolean. Actually, no. I think while heap is fine because I'm exiting if any of these cases are, yeah. That's fine. It's just like a while true kind of thing because the heap's never gonna empty out, but it's fine. While heap, okay. So element equals heap q that heap pop heap. Okay. So I need the running total also. I should start that out here. Running total equals 0. Total plus equals num. Okay. We want to multiply this by -1. Okay, if popped element is 1, you're good. So if LE equals 1, return true. If LE is less than running total, return false. And else if no. If element is less than running total, return false. Yes. No, it should be running total minus element. Okay, yeah, because it's always going to be less than, and then that's bad. Okay, yeah, because then if it was 8, you popped 8, your running total was, what was the case here?
Okay, I see what you got.
What was it again? It was like 835, I believe. Yeah, so the total of
No,
this.
it was like 735.
Oh, was it? Okay, my bad. Yeah, you're right. 735. This total is 15. Because if you just check 7 less than running total, yeah, 7 is always less than 15. But then 7 is not. 7 is also less than 50. What was it? 8 minus. Wait, no. It would be 15 minus 7, which is 8. So 7 is less than 8. So then that case does trigger. Okay, and if it was 9 that you popped out, 9 is greater than 8, so you're fine. So this one wouldn't trigger. Okay, that's fine. Okay, and this one is if LE mod running total minus element. Actually, no. So no, this is good, but I also need to set it. I need to update it. So if I'm just doing a partial check here, that doesn't help much. So I guess I should do it up here. Running total minus equals LE. Then that way I don't have to do this and just do a running total. And I can also just do this too. And it's not mod, it's %sign. If element mod running total equals 0, and running total equals 1, return true, else return false. Wait, no, this else, does this else hit every case? That might be bad. It should be elif le. I think that's good. Return. Oh wait, no, I don't need to. Oh wait, no, I do need to return something. So if the heap doesn't exist, if there is no heap, what is this? Do they care? Is return true?
You will always have a heap, I think.
Okay. So I don't need to return anything here. This should handle all the cases.
Well, you're not done yet.
Wait, there's more?
So you just handle the edge cases. What happens in the non-edge cases? Right. Can you walk through 17.3.5?
Oh wait, hold up. Running. Wait, I thought. Okay. Oh, I didn't pop them back in. Oops.
Yeah, exactly.
Alright, my bad. Okay.
You're not done.
Yeah. Okay. So else these cases. Yeah. Okay. And then heap q that heap push le times -1. Wait, no, not le. In this.
So technically, your line 30 and 31 should be else.
Wait, what? No, it's. Oh, you mean instead of doing the else?
Right. Because the actual else condition is what you're doing now.
Right, because we don't. Well, technically, that's correct logically, or like correct like writing it wise. But technically, you don't need to do else here because if any of these trigger, you're gonna return before you even execute any more line of code. But I guess this does look cleaner. Okay. All right. So in that case, I need to push back the subtraction. Okay. So just wait. So right now I have the largest element popped out, and then I have the running total that is already decremented by the element. So okay, so in this case, if it was 953, I popped out 9. My running total was 17, but I subtract 9, so my running total is 8 now. And then I need to subtract. Okay, wait. I need to oh, I need to put the mod in. I need to keep push le mod running total. Yeah, so 9 mod 8 would be 1. And that would push 1 back in. Yes, I think that is correct. Okay. Yeah, because these cases will exit, and then this one will be, that means it's greater than 0. And then
okay, but there's still two small things that need to change.
Is there now? Oh wait. No. This, oh my bad. This should be times -1.
Okay, that's 1.
Okay. And then okay, so I am popping each time I'm doing this. I have the 3 edge cases handled, and then I put it back in.
Right.
What else am I missing?
Yeah, running total is missing something.
It is? What do you mean?
Well, if you just push something in there, your total was the thing without.
Oh, no. No, I already updated it, right? So like, okay, so if I pop in the 935, right? I pop 9, right? Running total is subtracted by 9. So it's 8 at this point.
So it's 8 so far.
Yeah, 8. Okay, so then I check if element is 1, it's not. And then if element is less than running total, it's not. If element mod this is not. So yeah, these are not the case. So I push 1 back in.
Okay. So what
Oh,
is
okay, wait.
it?
Running total is actually, yeah, you're right. Running total is actually 9 because you push the 1 back in. So I need to update running total plus equals LE mod running total times -1. Okay, I should store this in a variable so it looks cleaner. So it should be new LE.
Oh, wait. Hang on.
What's up?
The heap is a min heap, but your total is a positive thing.
Yeah, and that's why I'm multiplying by -1. Oh, so new element is, yeah, new element is a positive number. Ooh, wait. Element is a positive number. When I mod running total, it's still a positive
Still a
number,
positive
and then I
number.
multiply -1 just to push into the heap. Okay, so this should not time. It should be new element times -1 here, and then this one should just be purely new element.
Right.
Yeah, there you go. Okay, that should be good.
Okay. Can we confirm that this works then?
Yes. So if I pop 9, then my running total is 8 at this point. Skips all of these. 8 mod. Well, no, it would be 9 mod 8 is 1. So I push 1 back in. I push -1 actually back in. My running total is updated to 9. So now I have 1, 3, 5. I pop out 5 here. And then I subtract 5 from running total, which was 9. So it's 4 now. 4 is the running total, and 5 is my element. So element's not this. 5 is not less than running total. 5 mod 4 is not 0, so it skips these. New element is now 5 mod 4, which is 1, so I push 1 back in. I push -1 back in. And then my running total is now 1, 1. It was what was it? 3. It was 4. It was 4 before. And now I'm adding 1 to it. So it's 5 again. So I have 1, 3, 1. So I'm going to pop out 3. Well, -3, which becomes 3. Running total subtracted 3 is 2. So 2 is my running total. Element is not 1. 3 is not less than 2. And 3 mod 2 is not 0. And then new element is 3 mod 2, which is 1. You push -1 back in. Update running total to 3. And then you pop out a 1. And running total right here, it doesn't really matter because it's going to exit here. So that works for 935.
Let me just try to custom test cases and make sure they match.
Yeah, alright, I'll throw in this one. And I'll throw in that million one too. And then what else did they have? They have this one and 8, 5. Let me just do 8, 5, and 8, 1. Yeah, it looks good. Cool. Oh, no. I am dividing by 0 somewhere. Integer by 0. Wait, running total gets to 0? The hell? How's that even possible? Oh, because I do it beforehand.
Wow.
Oof. Okay.
I see.
Yeah. Okay, so if it was just 2,
Wait, so there's another edge case where
it's just one element, right?
right,
Wait, if it's one element, you can't get to 1, right? It's impossible.
you cannot get to 1. That's right.
Alright, so I want to do.
Okay, if running total is 0, it's an edge case. We forgot. But you can't make any progress.
Yeah, if running total is 0, I can break there also. But I could exit before the heap. So I guess it's fine. So I can do if running total.
I mean, it's gonna be in your checking cases, but that's not strictly true. You should check it after the element is 1. Because you could start with 1.
Oh, right.
And total will be 0 in that case.
Okay, sure. Or I could have just checked it outside. If the length of the heap is 1, then you exit also. Or just length of target in general, actually. Like skip all that. Just literally first line.
No, because it could be 1, as we mentioned.
Oh. You're right. Okay, sure. Let's put 2 in here. Yep, that works. Alright, cool.
Very nice.
Very nice.
Okay. No, this is a hard problem. It's like it takes a while to figure out the edge cases and approach that is not like all over the place. So, very good. But I need to go do work now.
Alright, no. Wait, it's Sunday, dude, man. What the hell are you doing?
Yeah, no. Start of life. Okay.
GG's. Alright.